right, let me minimize that. All right, so y'all's first question is going to say, use an end behavior diagram to describe the end behavior of the given function. So these four diagrams, A, B, C, and D, those were the four choices we had on a chart we made. We had a chart, we said the degree was even or odd, and then on the side we said was the lead coefficient positive or negative. So we want to look on this, negative pi x6 plus x to the fifth minus x to the fourth minus x plus 4. The main thing we want to find is the degree of this polynomial and if the lead coefficient is positive or negative. So I'm looking for the highest exponent. So the highest exponent would be the 6. So 6 is even. So I know I got an even degree. And then the lead coefficient is at negative pi. Since that pi is negative, the lead coefficient is negative. So I got an even degree, negative lead coefficient. So if you looked on the chart, that was the one that was going downhill on both sides. So you would pick A on that and then move to the next one. And I think it's going to be similar. So basically the same problem, except they rearranged this. This one's not in descending order, so be careful, because the degree is the highest exponent, and y'all, the highest exponent here is a 7. So I got an odd degree. The 0.2 is the lead coefficient since it's in front of the variable with the highest exponent. And that 0.2 is positive. So when we had a odd degree and a positive lead coefficient, it should go uphill left to right, which would be B. All right, then we would move on. So now we're actually going to find some zeros. So I'll probably actually work this one out. So let me write down this number 3. It's going to be f of x equals x squared minus 9 in parentheses. And y'all, that's to the 4th power. So we're going to go to my pad and we'll work this out, and then we'll come back and put our answer in. So first thing I will say, since all this is inside the parentheses, the multiplicity is going to be that exponent 4 on the outside. Okay, because no matter what answers I get out of this, they're all going to happen 4 times basically. So to find the actual zeros, you take what's inside the parentheses, x squared minus 9, and set it equal to 0. And y'all, to solve this one, since I don't have an x term in the middle, I'm going to solve this one by taking square roots. So to do that, you would add 9 to both sides. So x squared equals a positive 9. Then you would take square roots of both sides. And remember, since I'm taking the square root of a number, I'm going to put the plus or minus in the front, because 2 negatives can make a positive and 2 positives can multiply to make a positive. So let's see what happens. Square root of x squared is an x. This is going to be a plus or minus. Square root of 9 is 3. So that I get, my answers will be x equals 3, x equals a negative 3. Okay, and if you put both of these numbers back in for this x, 3 squared is 9, 9 minus 9 is 0, and then negative 3. Negative 3 times negative 3 is 9, and 9 minus 9 is 0. So they both work, and both have a multiplicity of 4. Okay, so that outside exponent is the multiplicity on this one. That's right. Taking that x squared minus 9, and you would write it 4 times. That's basically what the exponent's saying. So since you got a repeating factor 4 times, that's why we just say, hey, we'll solve it once, but tell you that it happens 4 times, okay? All right, so we got plus and negative 3, and they had a multiplicity of 4. So we would go back there and put that in. Oh, and they got this one worked out for us. So they got plus or minus 9s. Nope. So we need plus or minus 3, plus or minus 3. But y'all watch out. This one has multiplicity 4. And I don't know where they got a multiplicity 8. So we don't want that for sure. We want B because of our multiplicity 4 by that 4. All right, doing that, then we would move on. Basically the same kind of problem, but they just want us to figure out, they're giving me the info here and I just got to fill in. So it says the 0, 1 has a multiplicity. Well, to get a 0, 1, you would have had to set the x minus 1 equal to 0, and that would have gave me a 0 or 1. Well, it's got an exponent right by it of a 2, so you would come over here and put in a multiplicity of 2 for that 0. And then it says here, blank is a 0 of multiplicity 4. Well, multiplicity 4 came from this factor right here with the x plus 2. And if you set that x plus 2 equal to 0, subtract 2 from both sides, you would get x equals a negative 2. So the 0 would actually be the negative 2. So the 0 is whatever number you can put inside the parentheses and make it equal 0, okay? So that gave me a negative 2 because negative 2 plus 2 is 0. And then it says the remaining 0 is, well, it's got to be this one with the x to the third because it's got the variable. This negative 7 does not have a variable, so it's just a constant term and we don't worry about it. But we're worried about this x to the third. I know that the 3 is the exponent that's going to be the multiplicity. So when you got a single variable, the exponent will be the multiplicity, and the only number that can be its 0 is 0. So you would set the x equal to 0, and that one would be done. So listen, single variables, x to the third, x to the fifth, x to the sixth, x to the anything, the 0 for it will be 0. Everything else will be in parentheses, and you find the numbers that make them equal 0, okay? All right, so that's all we wanted to do on that one. This one I will work. So let me write my number 5 down here. That is f of x equals x to the third minus 2x squared minus a x plus 2. So they want me to find the zeros and their multiplicities. So let's go to our screen. And you'll remember this one had the 4 terms. So this is the one that I did what I called factor by grouping. So the group, you would put the first 2 terms together and the last 2 terms together. You're going to find the greatest common factor on the first 2 terms and factor it out. So you got an x3 and a 2x squared. The only thing they got common is the variables. They both have x's. And the most x's they both have in common is 2. This one has 2 x's. This one has 3. So we would factor out 2 x's from each of those. So if I take 2 x's from an x to the third, that's going to leave me 1x minus, if I take these 2 x's from the 2x squared, that leaves me a 2. So basically, x to the third divided by x squared is x. Negative 2x squared divided by x squared is a negative 2. Now, we're going to take these last 2 and factor out a GCF from them. And remember, the second GCF has to have the same sign as that third term. So if that thing's negative, the GCF will be negative. So what does an x and a 2 have in common? They both don't have x's, But there is one number they both have, and that would be a 1. So if they have nothing in common, you at least have to factor out a 1. All right, negative x divided by that negative 1 makes that a positive x. And then a positive 2 divided by that negative 1 makes that a negative 2. So notice, my parentheses match up. So since the parentheses match up, I factor them out as one factor. And then in the other parentheses, I put what was on the outside of those two parentheses. So I take the x squared and the negative 1. So it's like you're factoring out the last GCF, and then when you divide both of these terms by the x minus 2, you end up with the x squared and then the minus 1. And remember, all this stuff is technically equal to 0 still, okay? So now, we factored the 4-term polynomial. So what we got to do now is set both of these factors equal to 0 so we can solve this. Now y'all notice they don't have no numbers outside of these parentheses, so we would put a 1 here and a 1 here, which means all the multiplicities will be 1. So let's set everything to 0. So set x minus 2 equal to 0. Set x squared minus 1 equal to 0. All right, so this one's not bad to solve it. You would just add 2, and I get x is 2 for my first 0. Now the second one does have a little bit more work because you got an x squared term. So since I got an x squared term and no x term in the middle, I'm going to solve this one like I did a while ago on this one up here and take square roots. So to do that, you would add 1, and you get x squared equals 1. Then I would take square roots of both sides, and since I'm doing a number, I got to use my plus or minus. All right, so square root of x squared gave me x. It's going to equal a plus or minus square root of 1, which is 1. So all my zeros I got a 0 of 2. I had a 0 of a positive 1, and I got a 0 of a negative 1. And all have a multiplicity of 1. So factor the 4-term polynomial until you get it down to this spot. And then at that spot, take both of these factors and set equal to 0 and solve them, okay? All right, so we want to go back to the test and put this in. All right, so this says the zeros are, we said we had a 2, comma, 1, comma, negative 1. And then each 0 has a multiplicity of 1, we said. So notice how I'm not putting the x equals on these. You got to be careful and watch these answers, okay? Because I get people that miss them because they'll put x equals 2, comma 1 inside the box. And then I just go back and try to fix them. So just watch for those. All right, so this was sort of a true or false. So let's see what they want to know. They're giving me a p of x equals x minus 4 to the 8th, x plus 1 to the 3rd. Then the graph crosses the x-axis at 4, 0. So to get a 0 of 4, it would have had to come from this factor of x minus 4. So remember, if the multiplicities are even, it touches the x-axis and is tangent. If the multiplicities are odd, like the 3, then it crosses the x-axis. So even they're tangent, odd they cross. So this one says it crosses at 4, 0. Well, remember, we just said if it was even, it was tangent at that point. So this would definitely be false because it doesn't cross, it's tangent. So now look down here, you got to find the right reason. It's false because x minus 4 to the 8th is a factor and the exponent 8 is even. So it's tangent, which is true. And notice down here they're saying, hey, the exponent 8 is odd. Well, 8 is not an odd number, so we definitely got to pick C for that. But y'all read those really close because there's only 1 or 2 things they change on them for the 2 false answers and for the 2 true answers. Plus, if you notice this, they got the x-intercept backwards. It should be 4, 0 and not 0, 4, okay? To be on the x-axis, the y value is 0, not the x. So just watch for the little tricks they try to do on those. All right, so for the function, find a maximum number of zeros, maximum number of x-intercepts, and maximum number of turning points. So I know the maximum number of real zeros is equal to the degree of that polynomial. The maximum number of x-intercepts is equal to the degree of that polynomial. The maximum number of turning points is equal to the degree minus 1 for that polynomial. So you got to find the degree, which is the highest exponent. So the degree of this is a 2. So since 2 is the degree, you can have a max of 2 real zeros, a maximum of 2 x-intercepts, and then a maximum of 2 minus 1, which is 1 turning points. Okay, so just use them rules for that. Write the degree twice, subtract 1 from it, and be done. All right, y'all, so let me write this problem down. X minus 2, x plus 5, and x minus 7. So I'm going to show you what I would look at on this, and then we'll go look at this 4 pictures they got. So they gave me this polynomial, so I want to know the degree of this, and I want to know if the lead coefficient is positive or negative, and then I'm going to show you other tricks I know. Okay, so the degree is going to be all the x's multiplied together. So x times x is x squared times x is x to the third, x to the third times x is an x to the fourth. Now, to find the lead coefficients, take the numbers in front of all the x's and multiply. 1 times 1 is 1, times 1 is 1, times 1 is 1. So notice this, degree is x4 is even. The lead coefficient is 1, which is positive. So I know anytime I got an x to the 4, which is even, and a lead coefficient, which is positive, I know in the long run, that graph's going to want to go uphill eventually, okay? So let me show you something else I would look at on this. Remember, all these are factors, and they all have an exponent of 1 by them. Since they all have exponent of 1, which is odd, all these zeros are going to cross the x-axis. They're not going to come down and touch it and be tangent. Since all these are odd ones, it's going to cross the x-axis at all these points. It's going to cross at this one, which is 0, remember. And this is x minus 2, so it's going to cross at 2. This was x minus 5, so its 0 would be a negative 5. And then this is x minus 7, so its 0 would be a 7. So you need a graph that's uphill on both ends, and it crosses that x-axis at 0, 2, negative 5, and 7. So let's go back to them 4 pictures. So look here. uphill on both sides. So there's no way it can be A. A only crosses 3 times and it's going uphill left to right. So this is a possibility. Notice both sides are going uphill. This one looks like it's coming up, goes down and goes up. So there's no way it can be that one. And this one is going downhill on both sides. So technically the only one I could be is B. And look at this. We said it's going to cross at 0 right there. There's a 2 it's crossing at. Crossing over here at -5. And then it's crossing over here at 7. So the only choice could be B on that. But y'all, if you remember, there was only one going uphill both sides. Okay, this one went uphill left to right, uphill left to right, and then this both sides went downhill. Okay, so pick your picture and move on. All right, same thing on this one, but this one's a little trickier. So I look at the degree 3, which is odd. So odd is either going to go uphill or downhill left to right. So it's odd degree. 10 is positive. So since it's an odd degree and the 10 is positive, it's going to go uphill left to right. Well, look at this. B is going uphill left to right, and D is going uphill left to right. So when they both go uphill left to right, you want to look at that last number, which is 24, because that's the y-intercept. So does B look like it's crossing 24, or does D look like it's crossing 24? So let me zoom this one in. And y'all, B looks like it's crossing right at the 0, which cannot be right. So let me zoom in D here. And if you notice, it looks like each one of these marks is going about 20 something. So if you look at that one, I would pretty much say that looks like it's going right over at about a 24. So I'm going to pick D for mine. There's no way it can be C because C is going downhill. And then A, both ends are going uphill. So we know the only picture is D. And I guess that's why they gave me 2 that looked the same on that one. All right, let's see what this 10 has. All right, so I'm going to write this one down. So now I'm getting into synthetic division. So this has f of x equals x to the 4 plus 4x to the 3rd plus 2x squared minus 4x minus 3. And I just want to know if these two numbers are zeros. So let's go to our pad and work this one. And y'all, since I'm checking these two numbers, -2 and 1, I will be doing my synthetic division twice, okay? So the first thing we're going to do is write down all of our numbers, and it don't look like I got anything missing, x4, x3, x2, x, and my number, so I don't have to worry about no zeros. So let's write our numbers. I got a 1 for the x4, a 4 for the x3, a 2 for the x squared, a -4 for the x, and then my constant term is a -3. And then I'm going to draw my little box. And remember, that's my remainder. So the first number I'm checking to see is a 0 is -2. If -2 is going to be a 0, then the remainder has to be 0, okay? So if I get a 0 remainder, it's yes. Anything else will be no. All right, so we bring the first number down. So bring the 1 down. And then you're going to, any number that's down here multiplies by this number to get the next column. So 1 times -2 is -2. Add them up and down. 4, -2 give you 2. Then you repeat the process. 2 times -2 is -4. 2 and a -4 give you -2. Repeat the process. -2 times -2 is 4. -4, 4, is 0. Then you repeat the process. 0 times -2 is 0, which y'all be careful. -3 plus 0 is a -3, which means this answer is no. -2 is not a 0. So that means if I put -2 in for that equation, it's not going to equal 0. All right, so let's write the numbers and check the next one. 1, 4, 2, -4, -3. Then I make my little box. And this time the number I'm checking is the 1. So the two numbers with the what do you call it, a comma, are the numbers they want you to check for on this, okay? Now we're going to do the same thing. The 1 comes straight down. 1 times 1 is 1. 4 plus 1 is 5. And then we repeat the process. 5 times 1 is 5. 2 plus 5 is 7. Then we repeat the process. 7 times 1 is 7. -4 and 7 give me a 3. Then we repeat the process. 3 times 1 is 3. Uh-oh, y'all, -3 plus 3 is 0. So that would be a yes. Now, when you put your answers in, you got to go in the same order as these zeros they gave you. It's got to be no, yes when we put this in, okay? So let's go put that in. So what did we say? No, yes. So the first one, -2, was a no. And then 1 was a yes. Now look, they're trying to be tricky here. They got no, yes here, and then they got yes, no. So watch for them changing the order on the answers even, okay? That's sort of sneaky, I think. All right, let's see what's next. I bet we're going to have to find a polynomial pretty soon. There we go. We got to find a polynomial degree 4 with zeros, -1, multiplicity 3, and 0, multiplicity 1. All righty, so let's go FOIL this thing out and come back and put our answer in. So where are we at? There's my pad and share. So degree 4 means when I'm done, I'm going to have an x to the 4 as the biggest exponent, okay? So remember what we said, multiplicity tells you how many times you got these answers. So I got -1 3 times. And then I got 0 1 time, so that'll just be an x equals 0. So now, anytime I got x is equal to 0, I put them up front. So watch me, I'm going to solve these and put these ones in parentheses. But the one that equals 0, I'm just going to leave alone. So the other 3, though, I will add 1 to both sides. Okay, because you want to get them in factored form. Okay, so my 4 factors are x plus 1, x plus 1, x plus 1, and x. So what I'm going to do is take this x and put it first, and then all the x plus 1s I'm going to put in parentheses. And all this is going to equal 0, basically. Y'all, many ways you can FOIL this. You can FOIL this x first, and then get that answer, and then FOIL, and then get that answer, and then FOIL. What I'm going to do is do 2 of these at a time. I'm going to FOIL these 2 together, and I'm going to distribute this one. So I'm going to distribute on the first one, and then I'm going to FOIL on the second one. So that's still going to give me 2 big sets of parentheses. That way, you can sort of do them a little quicker, okay? Do 2 things at once. So here we distribute. X times x is x squared. X times 1 is a positive x. So that is quick when you distribute. The FOILing will take a little bit more time. X times x is x squared. x times 1 is 1x. 1 times x is 1x. And then 1 times 1 is 1. So before I FOIL this last thing, let's add these like terms in the middle. So bring down the x squared. 1x plus 1x gives me 2x plus my 1. All this is still equal to 0. Now, instead of me foiling and then foiling again and then finally distributing, now I can FOIL this and be done. So this x squared multiplies by all three of these, and then this x multiplies by all three of these. So x squared times x squared is my x to the 4. X squared times 2x is a 2x to the 3rd. So only changing exponents on this round. X squared times 1 is x squared. So basically all these went up by 2 x's. From 2 to 4, 1 to 3, none to 2. Numbers all stayed the same. Now do the x times everybody. X times x squared is an x to the 3rd. X times 2x is a 2x squared. And then x times 1 is a 1x, all equal to 0. So now let's combine all the like terms. And I'm going to put them in descending order. So the x4 is first. Let's see, I got 3x3s and 1x to the 3rd. So that'll give me 3x to the 3rds. I got 1x squared adds to 2x squareds. That gives me 3x squareds. And then y'all, at the end is a positive x. So what MATLAB wants us to come and put in is this little polynomial right there. That is a degree 4. But like I said, there's many ways you could have FOILed this. I just did 2 at a time so that I can sort of save me a little paper and all that kind of stuff, okay? All right, so let's go see how they want this put in. And it says use a 1 for the leading coefficients. Okay, so they must want me to put in a 1x to the 4th. So that's going to be tricky now. Coming down here, getting my exponent 4. Then you got to arrow over plus 3x to the 3rd. So let me come get the exponent 3. Arrow over. Then I had 3x squared. So plus 3x squared. Whoops, I needed the x. Oh, my bad, y'all. So let me delete. So 3x squared. So let me get the square now. And then what was at the end? Plus x. All right, so let me go back. And I need to put a 1 here, apparently, because it says use 1 for the leading coefficient. All right, so we got that in. Then we will go to the next one. All right, so let me get the paper ready. All righty, so this one don't take much work. So they're saying, suppose a polynomial degree 4 has the following zeros, find the other 0. So a degree 4 would have 4 zeros, and they're giving me 2 of them, y'all. This is 2. One of them's I, and then the other one is 9 minus square root of 11. Well, remember, I's always come in conjugate pairs. So if I is a 0, then negative I has to be a 0. So you would hit negative and then get the I, and then a comma. If 9 minus square root of 11 is a 0, then 9 plus. So then you would do 9 plus square root down here, and then put in 11. So that's all you had to do on that one was remember that these all come in conjugate pairs, okay? They're going to give you some of the zeros, and you just got to find the opposites by knowing that information. So now I got to find the polynomial of lowest degree, and it has zeros of a square root of 5, and that looks like a 5i. All right, so we're going to go FOIL this one out. So remember, the question I just had a while ago wanted me to find the missing zero. This one wants me to take the zeros and find a polynomial of lowest degree. Well, I know if square root of 5 is a 0, then negative square root of 5 has to be a 0. And I know if a 5i is a 0, then a negative 5i has to be a 0. So this is one of those where we're going to set everybody equal to 0 and then start foiling. So x equals a square root of 5, x equals a negative square root of 5, x equals a 5i, x equals a negative 5i. I'm just matching them together, the i's together and the radicals. Subtract and add to get everything with a 0. So subtract square root of 5. So x minus square root of 5 is 0. This one we will add. So x plus a square root of 5 is 0. And then subtract 5i from this one. And add 5i to the last one. Or y'all, when you see this, change its sign and put it behind them x's, right? All right, so now I got them how I want to, so I'm going to have 4 sets of parentheses with my factors. Now, when I FOIL, I will FOIL these two together and these two together. But since these are conjugate pairs and these are conjugate pairs, I'm going to shortcut FOIL. So that I don't have to worry about canceling the middle stuff that's going to cancel anyway. To shortcut FOIL, you do the first two terms together. X times x gives me a x squared. And then you multiply the last two terms together. Well, a negative and a positive is going to make that a negative square root. 5 times 5 is 25. So I shortcutted those, and I didn't have to worry about adding like terms because I knew they was going to cancel. And then in a second, we'll take care of that right there, okay? So shortcut for all these ones. The first two get multiplied together. X times x is x squared. And then the last two get multiplied together. Negative times positive is a negative 25i squared. So y'all know I didn't have to add like terms. Anytime you have conjugate pairs, you can do this shortcut FOIL into it, okay? Now, before I FOIL these, I'm going to simplify some of this stuff. I'm going to bring down the x squared minus, well, I know the square root of 25. Square root of 25 is 5. Over here, x squared minus 25i squared, well, y'all watch this. Negative 24 second decimal to bring up the I, and then squared it is going to equal a positive 25. So remember, I squared equals negative 1, and that negative times negative makes that a positive 25. So check this out. Radicals always FOIL to be negative. Imaginary numbers always FOIL to be positive. All right, now that I got just numbers here, I'm going to FOIL this and be done. Now, these are not conjugate pairs, so I can't shortcut it. I got to actually FOIL it all out. So the x squared times x squared is the x to the fourth. X squared times 25 is 25x squared. Negative 5 times x squared is a negative 5x squared. And then negative 5 times 25 is a negative 125, all equal to 0. And y'all, if you notice, the last thing is to add like terms. So bring down that x to the fourth. 25x squared minus 5x squared will leave me 20x squared minus my 125, all equal to 0. So MATLAB should want my little polynomial right there. Okay, so let's go put that in. So y'all, I'm not gonna lie, you got a few on here. We had to do a little bit of foiling to them, okay? So this one don't tell me I got to use ones for my variables. So I'm just gonna go x, exponent 4, arrow down, plus 20x squared, arrow down, minus, whoops, backspace, minus 125. Okay, so just find your little polynomial and put it in and then move on. All right, so y'all, that's halfway. Any questions? All right, so this is one of those. So let's write this. So this is f of x equals x to the third plus 6x squared minus 3x minus 18. And they're giving me negative 6 is a 0, and I got to find the others. All righty, so let's go to our screen. So since they're giving me 1 0 is negative 6, I know that since that's a degree 3, I got 3 zeros altogether, and I know I can get the last two doing some kind of quadratic equation. So I got to knock out this one first. So we're going to bring our negative 6 over here to be the number that I'm going to be running through my synthetic division. So let's see, 3, I got an x squared, an x, and a number, so nothing's missing. So I got a 1 for the x3, 6 for the x squared, negative 3 for the x, and negative 18 for the constant term. Now, here's how you know you're doing synthetic division right, because they told me that was a 0. That remainder better be 0 when I'm done, okay? Because what I'm looking for is what kind of numbers are going to end up right in here. This quotient, these three numbers, I'm going to determine whether I use the quadratic formula or square rooted, okay? All right, so let's go. Bring the 1 down. 1 times negative 6 is negative 6. 6 plus negative 6 is 0. 0 times negative 6 is 0. Negative 3 plus 0 is negative 3. And y'all watch this. Negative 3 times negative 6 is 18, which gives me a 0 remainder. So the main thing I was worried about was these three numbers here. So remember, this all starts out 1 degree less than that one. So since that was an x3, this is going to start out as 1x squared plus 0 x's minus 3. Okay, that's what these terms are giving you. Had I had a number here, then I'd have put an x in the middle. All this to find my last zeros is going to be set equal to 0. So y'all solve this by easiest way is to square root it. So add 3, add 3. So I get x squared equals 3. And then remember, I'm going to do square roots. I'm doing square root of a number, so I got to put a plus or minus. So y'all, let's see what happens. Square root of x squared is x equals plus or minus square root of 3. It has no square root because we don't want decimal answers. So since this does not come out as a perfect square root and it can't be simplified, I get a plus or minus 3. So MATLAB will let you either put square root of 3 comma negative square root of 3, or I think it actually has the plus or minus option. So let's go find out. So MATLAB. So let me click in here. Oh yeah, and they do got a plus or minus here. So hit the plus or minus and then grab that radical, and under the radical, we're going to put our 3. Okay, so that we got our plus or minus 3, and then we can move on. All right, 15, let me write my numbers down so I'll show you what we're doing here. F of x equals 18x to the 6th plus 16x to the 3rd minus 18x squared, plus 18x plus 7. So I wrote down the polynomial. Now I'm going to find all possible rational zeros. It's not a bad problem. It's just tedious a little bit. Because remember, all the rational functions, I'm going to take all the factors of the last number. So all factors of last number, and divide all them by all factors of the first number. And in front of all that, I will put a plus or minus. So what's the factors of the last number? Well, the last number is 7. So the only factors of 7 are 1 and 7. Now here's the tedious one, 18. 18 can divide by 1, 2, 3. What's next? 6, 9, and 18. And I think that's it, right? 9, yeah. So what we want to do is find all the combinations where we can take these numbers, 1 and 7, and divide by all these numbers. And in front of all those will be a plus or minus. So let me start with this 1. I would divide 1 by 1. I would divide 1 by 2. I would divide 1 by 3. I would divide 1 by 6. I would divide 1 by 9. And then I would divide 1 by 18. Now notice, this one here will simplify, so I'd have turned that into a plus or minus 1. And then everything else don't simplify. So then I would do that with the 7. I'll do plus or minus 7 divided by 1, plus or minus 7 divided by the 2, plus or minus 7 divided by the 3, plus or minus 7 divided by the 6, plus or minus 7 divided by the 9, and then plus or minus 7 divided by the 18. But remember, this one, 7 over 1, would reduce to just a 7. So if any of these would simplify, you got to. So that's all the possible zeros for that polynomial, which means the real zeros have to be one of these, okay? So we would go back and watch them. They're a little tricky on these answers here. You got to pay attention to some of them. So notice, this one don't have my 1 in it at all. So since it ain't got my 1, I'm skipping it. Hey, there's my 1, and then I got a 7. And then look at all my numbers. There's my half, my third, my 6th, my 9th, my 18th, 7 halves, 7 thirds, 7 6, 7 9, 7 18. So B looks good. Look at C. They took the bottoms and divided by the top numbers, which we can't do. And in here, they just, I don't know what they did to that. But all you do is find all the combinations of your numbers, find which answer has that, and then y'all moving on. All right, 16 here. I'm going to work this, but I took this one off my test. So you can put a star by it because it'll be one of the 5 that get taken off. Oh, what's that? 98x plus 343. Because these ones have a lot of guessing to find those first zeros. And then I didn't like that linear factor stuff it does. So we're going to find all of our zeros and then factor it into linear factors. So let me share screens. All right, so the easiest way to find some of these zeros is to go and graph this thing. And let's look where it crosses the x-axis. So here goes 2x to the third plus 7x squared plus 98x plus 343. So I just want to see if the graph and see if I can tell where that's crossing those x-axis at. And y'all look at that. That looks like that's at -1, 2. Looks like that's at a -3.5. Okay. So let me show you some combinations on these numbers. So I guess I'm going to have to break that out after all. So factors of 343 would be 1 and 343. So let me go to this page. I know 343 divides by 7. So I know 7, 49, and then 343. I think 7 is the only numbers that goes into this. So those are all my factors of 343. And then all my factors of 2 would be 1 and 2. So you would take all these numbers and divide by these numbers. So 1 divided by 1, which is 1. 1 divided by 2. Then I would take the 7 divided by 1, 7 divided by 2. 49 divided by 1, 49 divided by 2. And then the 343 divided by 1, 343 divided by 2. So that equals 1, that'll equal 7, that equals 49, and then that equals 343. Look at that graph. I need one of these numbers that is around a 1, 2. Looks like that's about -3.5. So which one of these numbers would give me a 3.5 when I divide? Well, I know 1/2 is 0.5. 7 divided by 2. Oh, look at that, 3.5. So that's going to be the first number I run on my synthetic division. And it's going to be negative because that's crossing that graph right there at that -7/2, okay? So you would bring down your -7/2. Bring down your coefficients. 2, 7, 98, and 343. And nothing was missing. So if I'm right and that's a 0, my remainder will be 0, and then I can use these numbers here to get the last 2 zeros, okay? And y'all, I didn't feel right making y'all do this crazy problem with a fraction even, okay? All right, so here we go. Bring the 2 down. 2 times -7/2. 2 times -7 divided by 2 is going to give me -7. -7 and 7 add to get 0. 0 times a -7/2 is 0. 98 plus 0 is 98. And y'all watch this. 98 times -7/2 is a -343, which adds to my 343 to give me a remainder of 0. If you pick the wrong 0, you will not get a 0, and you have to find another number to use, okay? Now that I know that that was a 0, my first 0 was -7/2. Then I would come in here and pick which method I want to do. So remember, that's going to be a 2x squared plus 0x plus 98, we said equal to 0. And y'all, this one's still easier to do by square roots. Watch this. Subtract 98 from both sides. You get 2x squared equals a -98. divide by 2 before you do that square root, because you want that x squared to be nice right there. Negative 98 divided by 2 is a negative 49. Now I would do my square roots, because you always want the variable by itself. So square root of x squared equals a plus or minus square root of negative 49. So that x equals a plus or minus. Now y'all watch out. Square root of negative 49 is not 7. Watch this. Second square root, negative 49 is going to equal a 7i. So I get a plus or minus 7i. Remember, if you got a negative inside, it comes out as a imaginary answer, okay? So negative 7/2 was a 0. 7i is a 0, and negative 7i is a 0. So those were my zeros. Then it wanted me to put them in linear factors, and that just means put them all in parentheses. So since that's negative, it would be a 7x plus 7/2. Since that's a positive 7i, it'll be x minus 7i. And then since that's a negative 7i, this would be x plus 7i. Now, if you're doing this for the review, since you got a fraction with a denominator of 2, you would technically put the 2 in the front. That way, when you start foiling, it would cancel the fraction and everything would come out in nice numbers, okay? So, I got my answers there, so let me see what MathLab lets me do on this one. So now watch this. I got rational zeros, which are the fractions, but I got imaginary zeros. So I need this one that says, hey, there's only one rational zero, and that was the negative 7/2. So I would do negative 7 divided by 2. And the other zeros would be when I get a plus or minus 7i. So you gotta be careful which answer you picked on that. And then y'all, I'm not gonna do this, but this is where I would put all the parentheses in there, the 2, the x plus 7/2, x minus 7i, and then x plus 7i. So imagine I've done that, and then we moving on. Yes, we want to leave. See, it'll try to keep you on track if you leave before something's all the way done. All right, find the domain. So let me write this big old fraction down. X to the third minus x squared plus x plus 5, all divided by x squared plus 13x plus 40. Alrighty, so let's go to the screen, because there's only one thing we're doing to find a domain. To find a domain of a fraction like this, we take the bottom, x squared plus 13x plus 40, and we say it cannot equal 0. And then we solve that. So I'm going to solve it by factoring, but if you can't factor this, you can always use the quadratic formula, okay? In the front would be an x and an x. Last number is positive, so both factors have the same sign as the middle. They're both positive. And then factors of 40 are 1 and 40, 2 and 20, 4 and 10, 5 and 8, 6, 7 don't work. So that's all the factors of 40. One of those will add to get 13, which will be 5 and 8. All right, then you take both of those and not equal to 0 those. So to solve this one, I would subtract 5. So x cannot equal a negative 5. This one I'm going to subtract 8. So x cannot equal a negative 8. So let me see what they want me to do. Was it interval notation, or did they want me to put them in set builder? So let's see. Oh, it's got them both. So in set builder notation, we know x is a real number and x cannot equal Now I had two answers, so I'm going to go down here. Now notice it says use ascending order. So go from the smaller number to the bigger number. Well, -8 is the smaller number between those. And then my -5 would be the larger number. And then they want me to put it in interval notation. So that's why they want you to do ascending order here, because going left to right, you would hit -8 first and then the other one. So remember, you would start at negative infinity until you hit -8. Then you would go over here and union from -8 to the -5. Then you would arrow over and union from the -5 to a positive infinity. So these always start at negative infinity on these domains and go to positive. You just kick out the numbers in here, and you got to go left to right. So that's why they did that right there to us, okay? All right, I think the next one was the same thing, y'all, another domain. So find the domain of the rational function. So I got f of x is going to equal 1 over x squared plus 2x minus 35. So let's go solve that in real quick. Same thing, y'all, to solve this one. Take that bottom and set it not equal to your 0. This one I'm going to factor again. But you can use a quad on this if you like doing the quad formula. So I got an x squared, that'd be an x and an x. Anytime the last number is negative, you got one positive and one negative. Now, since that's negative, you want factors of 35, that's subtracting it 2. So 1 times 35, what's next? 2, 3, 4, 5 times 7. So that's the only two combinations. The only numbers that subtract and get a 2 are 7 and 5. Since the middle number is positive, the larger number is positive. So make the 7 positive and the 5 negative. Now set both of them equal to 0. Well, we said not equal to 0, right? So this not, since it's added, I'm going to subtract 7, and x cannot equal a -7. This and I would add 5, and x cannot equal a +5. So interval notation starts at negative infinity. First number I would hit going left to right would be the -7. Union around -7 till you hit +5. Union around that 5 until you hit positive infinity. Okay, y'all, so I'm going to give this a break real quick. So let me stop my share. And I'm going to pause our video. All right, so let's continue on with this test. Okay, so we just did this one. I did that domain for you. So let's move to the next one. All right, 19. I'm going to do, but put a star by this one. I took this one off the test, okay? So let me write what they got. They got an r of x equals 5 over x squared minus 36. They want me to find vertical asymptotes, horizontal asymptotes, and then it shows oblique, but put no oblique on these, and then we'll pick our picture. So let me show you what I would do to find my horizontal and my vertical asymptotes. So to find my vertical asymptotes, I would take the bottom and set it not equal to 0. So since there's not an x term in this one, the easiest way to solve this would be by those square roots. So I'm going to add 36 to both sides. And then square root. But remember, since I'm doing a square root, I got to do a plus or minus square root on that 36. So that x will equal, well, it cannot equal a plus or minus 6. Okay? So my vertical asymptote would be x equals 6, comma, x equals -6. I think we have to put these in like in an equation, okay? Now, horizontal asymptote, I look at the degree of the top versus the degree of the bottom and see which one's bigger. Well, if you notice, there's not even a variable in the top, so it has no degree. The bottom has a 2, so the bottom degree is bigger than the top. So anytime the bottom is bigger than the top, your horizontal asymptote will be y equals 0. If the top's bigger than the bottom, there's no horizontal asymptote. And if they're equal, then you look at the numbers in the front, okay? So horizontal is y equals 0, vertical at 6 and -6. So that should have been the only things they wanted me to find on it. So now we can put that in and pick a picture. So type an equation or equations. So right here I would put x equals 6. So x, ooh, let me put his keyboard down, equals 6, comma, x equals -6. So they got to look like an equation. Okay, there's no oblique, so don't worry about that. The horizontal asymptote is y equals 0. So I would come in there. Where's y at? Y equals 0. All right, so then to pick the picture, you would find the one that had the asymptotes at 6 and -6. So that's possible. So it looks like they all got, well, this one don't have the one on the right. So it can't be C and D. It's got to be A or B. So we know it's got a horizontal asymptote at y equals 0, but that looks like it's going to 0, and that is going to 0. Okay, let's see. That's not crossing. That's not crossing. So what we got to do is put a 0 here and see if this is going to be negative down here, or is it going to be positive, and find a y-intercept. So if you put a 0 there, you get 5 over -36, which means it's negative. So since it's negative where it crosses the y-axis, you got to use A versus B. Had that been a plus 36, then we went with B on that, okay? Ooh, they're getting tricky on some of these. But I took that off because I didn't like y'all having to guesswork on some of that. All right, what's next? 20, you got to actually do. So 20 was determine the vertical asymptote. So we got g of x equals x to the third over 5x to the third minus x squared minus 6x. So if you notice the top, you got single variable x's. So what we need to do is play with this bottom and see what factors we get out of it. So to factor the bottom, since they all have an x, you would factor out an x. That would leave a 5x squared minus x minus 6. And y'all, what I would probably do here to find these two numbers, set this thing equal to 0. This one I know is going to equal 0 because it's by itself, right? So I would set this part, A would be 5, B would be -1, and C would be -6. I'm going to use the quad. A lot of people have trouble factoring when there's a number in front like that. So I'm just going to use.
Doing the problem.
Say again now.
You don't
Oh,
see
did I not share my screen?
no.
Ah. All right, so let me write this over and start over a second. So I got g of x equals x to the third over 5x to the third minus the x squared minus 6x. All right, so let me share this one. Oh, I get bad at that sometimes. All righty, so remember this x third is like an x times an x times an x on the top, okay? On the bottom, you got a 5x third minus x squared minus 6x. So what I need to do is factor that bottom and see what kind of factors I'm going to get. So the first thing I looked at, since that's the x3, I noticed they all had an x in them. So I would factor out one x and then put everything else that's left in my parentheses. So when you factor out an x, that leaves 2 here, 1 here, and none here. Then I'm not worried about this x at the moment because I can set it equal to 0 and be done. But what I need to do is take the 5x squared minus x minus 6 and set that equal to 0. So I'm going to use the quad on this. A is 5, B will be -1, and C will be -6. So it's x equals -b plus or minus square root of b squared minus 4 times a times c all over 2 times a. So b was -1. I put that in for those two. A was 5, so that goes on top and bottom. And then c was -6. So negative times negative makes that a +1, plus or minus. -1 squared is 1. Now, y'all, this side all multiplies together. So -4 times 5 is -20. -20 times -6 is a +120. All over 2 times 5 is 10. So let's keep working under here. So bring down to 1 plus or minus. Square root 1 plus 120 is 121 all over 10. So now take the square root of that 121. So you get 1 plus or minus 11 all over 10. So remember, when you got numbers, you got to find your first and second answer. First answer is 1 plus 11 divided by 10. Well, 1 plus 11 gives me 12 over 10. And y'all, we can reduce 12 over 10 to a 6 over 5. Second answer will be 1 minus 11 over 10, which gives you a -10 over 10, which gives you a -1. Now remember, since you had single variables on the top, a single variable cancels out this asymptote. Okay? But there's no factors on top that have a -1 and a 6/5, so I keep both of those. So my vertical asymptotes would be x equals a 6/5, comma, x equals a -1. So single variables will cancel with a single variable on the top, okay? Although that's got an exponent of 3, it still would be considered a single variable. So we would want these two, 6/5 and -1, on that MATLAB. So type an integer. So I would do x. Oh no, hold on. Now see, I don't need to put the x equals on this one because they got it. So all I would do would be my 6 divided by 5, arrow over, comma, and then my other one was a -1. So y'all, when you put them in, watch for what they're saying down here, and then look what they're giving you. This one actually gave me the x equals, so I'm only going to put in the two numbers. All right, 21 don't require no work, really. So they want us to find the horizontal asymptote. So there's 3 cases. The top's higher degree than the bottom, bottom's higher degree than the top, or they're equal. So the top has an x squared, degree 2. Bottom has an x4, degree 4. 4 is bigger than 2, so the bottom is greater. So this is just going to be y equals 0. So anytime the bigger on the bottom, you go y equals 0, and then you move on. All right, 22, I took off the test, but I will work it. X squared plus, that looks like an 8x plus 15. All right, so they want domain, x and y intercepts, vertical asymptote, horizontal asymptote, oblique, there'll be none. And then graph it. Okay, so let's see if I can actually share my screen this time. All right, so domain. First of all, the domain, I'm going to take the bottom, set it not equal to 0. All right, so I would solve that. I can factor this one. X and x, that's a positive 15, so both of these will be positive like the 8. And then factor the 15 that add the 8 are 3 and 5. And then I would solve those by subtracting. So let's see, that's going to give me what, a negative 3. So x cannot equal a negative 3. This one will give me a negative 5. So x cannot equal a negative 5. Now, doing my domain in interval notation, I would start at negative infinity. I would hit negative 5 first, union around that negative 5 until I hit negative 3. Union around that negative 3 until I went to positive infinity. So on fractions, you're going to have a negative infinity at one end and a positive infinity. You're just going to exclude numbers in order, left to right, okay? So that would be the domain. The x-intercepts, so the x-intercepts, I would find by setting the top equal to 0. But y'all, when I factor this, I'm actually going to factor that bottom, which I already know. So the bottom factored into what? A x plus 3 and an x plus 5. So let's factor this top and see what it gives me. I got an x and an x. That's a negative 20, so I got 1 plus and 1 minus. Factors of 20, that'll subtract and give me 1, or 5 and 4. The larger one has to be the same as the middle positive and the 4 negative. So that when I solve these, this one will give me what, a negative 5, because I want to subtract 5 from both sides. This one will give me a positive 4, so I get x equals 4 and x equals negative 5. But remember, so the top was the x plus 5, x minus 4. Remember, zeros and vertical asymptotes can cancel each other. So you got an x plus 5 on bottom. It's going to cancel the 0 of an x plus 5, because you can't have a 0 where this thing is undefined. There's no way. So that the x-intercepts, I would actually cancel out that one. So the x-intercept would be x equals 4. But remember, it's got to be like a point. So that would be 4, 0. At this one, it'd make a hole in the graph, okay? All right, so there's only one x-intercept. Y-intercepts. Y-intercept, you find f of 0, which means put a 0 in for all the x's. So 0 squared plus 0 minus 20 over 0 squared plus 8 times 0 plus 15. So all these are zeros. So basically you get a negative 20 over 15, which will reduce to a negative what? 4 thirds. So y-intercept's got to look like a point. So the y-intercept has a 0 for the x, because that's what I put in for all the x's, and then a negative 4/3 for the y value. All right, I know how to find vertical asymptotes. That's by setting the bottom equal to 0. Remember, this one canceled out with the, so vertical asymptote canceled with a 0. So the only vertical asymptote I got to worry about is the x plus 3 equal to 0. Remember, subtract 3 from both sides. So I get x is a negative 3. That's the only vertical asymptote. At this asymptote, remember, at the negative 5 one, it made a hole in the graph. All right, then that was the, oh, one more thing. Let's find the horizontal asymptote right here real quick. So look at this. The degree on top is a 2. Degree on bottom is a 2. So the horizontal asymptote is y equals a over b, which is the numbers in front. Well, there's a 1 there and a 1 there. But 1 over 1 equals 1. So the horizontal asymptote is y equals 1. So circle that. So remember, since they were equal, I had to look at what numbers were in the front. That's the a and the b. And 1 divided by 1 just made that a positive 1. All right, so hopefully I got enough now that I can go find me a graph on this thing. So new share, go to the graph. All right, so I'm not going to put all this in there, but it wanted interval notation like we said. We had an x and a y-intercept like it said. So I'm going to go down here and just look at pictures. So remember, I had a vertical asymptote at negative 3. So that one's at positive 3, so no way it's that one. Could be that one at negative 3, and it could be that one at negative 3, and then that one is positive. So then x-intercept was 4, 0, so it's crossing the x-axis at 4. Oh, hang on. Yeah, 4, 0. So notice this one made a hole. So that can't be it. It's got to be this one where it sort of crossed over. And then let's see, y-intercept was 0, negative 4/3. See, this one's negative, and that one's positive. So we would have to actually pick C on that one if we were doing that question. Ooh, see, that's why I took that off. That thing had a lot of info, okay? All right, so same thing on 23. I took this one off because it was really long. So we'll just work it real quick. That's what a x squared plus 2x over 4x to the third minus 7x squared minus 2x. So same thing, domain, vertical asymptotes, horizontal asymptotes, x-intercept, y-intercept. And then they're graphing it again. So let's go to our page and work this one. Oh, I thought these were sort of long here, okay? So the domain is still going to be taking that bottom, setting it equal to 0. So that cannot equal 0. So this one has an x3, so you're going to factor out an x first. That'll leave a 4x squared minus 7x minus 2 not equal to 0. All right, so y'all watch the top. When we get to these vertical asymptotes, since I had this single x, I'm going to get single x's on the top, so I know I'm going to cancel zeros again and vertical asymptotes, okay? So this part right here, while ago, I did the quad on that. Well, this time, I'm actually going to factor it. So you would set out 2 parentheses. In front of those would both be an x. The last one's negative, so one of these is positive, one's negative. So now watch how I find my numbers. When you got a number in the front, you got to take the number and multiply. So 4 times 2 is 8. So 8, we need to find factors of 8 that'll subtract and get that 7. That would be 8 and 1. The larger number has the same middle sign as the middle, so the 8 would be negative and the 1 would be positive. Now notice I'm leaving them up a little high because anytime you multiply the last number to get the product you're looking for the factors out of, you got to divide both them factors by that first number, which is the 4. So watch what happens. This one does not reduce, so what you got to do, if you were wanting to put this in factor form, is move the 4 in front of the x, so you get a 4x plus 1. This one, 8 will divide by 4 and make that a 2. So that would be factored now. So if you wanted to check it, 4 times x is 4x squared. 4x times 2 gives you negative 8x. 1 times x is x. Negative 8 and 1x give you negative 7. And then 1 times negative 2 gives you negative 2. All right, so I've got everything factored. And remember, this x is technically still in the front of that, okay? So take all 3 of these factors and set them not equal to 0. And solve. So that one's done. This one you would subtract 1 and then divide by 4 so that x is not equal to a negative 1/4. Now what's neat, you get a negative 1/4 here. Up here you had a positive 1/4. This factor looks like it's going to give me a positive 2, which up here had a negative 2, and then that's my 0. So the domain has 3 numbers that cannot be in it. So you would start at negative infinity. Let's see what's first. Negative 1/4. Union around negative 1/4 until you hit the 0. Union around that 0 until you hit the positive 2. Whoops. And then union around that 2 until you hit positive infinity. So now you see why I sort of didn't like this one on my test, right? Alrighty, so that took care of the domain. So the vertical asymptotes, I know what the bottom gave me for the 3 numbers, 0, negative 1/4, and 2. So let me see what the top would give me. If you factored the top, they both have an x, you would factor out an x, and that would leave you an x plus 2 in parentheses. So for the vertical asymptotes, this single factor x would cancel with that single factor x. So the only factor left would be the x plus 2. And notice the bottom had an x minus 2, but not an x plus 2. So vertical asymptotes, the only thing left would be the x equals, where am I at? X equals negative 1/4, x equals positive 2. So the vertical asymptotes are basically the same as the domain, except you got to look for the factors that might cancel with the top, okay? And that's why I didn't have to work that again because I already had these 2 solved. So here's my 2 equations. Horizontal asymptote, the degree of the top is 2. The degree of the bottom is 3. 3 is greater than 2. So since the bottom degree is higher than the top degree, horizontal asymptote is automatically y equals 0. All right, x-intercept. Well, I said this x factor from the x-intercept canceled with the x factor from the vertical asymptotes. So the only thing left is the x plus 2. Set that equal to 0. Solve that by subtracting 2. You get x equals negative 2. But remember, you got to put it in the form of a point, which would be negative 2, 0. And in the y-intercept, we said was finding f of 0, which would be 0 squared plus 2 times 0 all over 4 times 0 cubed minus 7 times 0 squared minus 2 times 0. Y'all, what's the bottom going to give you? 0 minus 0 minus 0 is a 0. So can we divide by 0? No. This thing is undefined, which means there's no y-intercept. But we knew that over here because at 0 we said u was undefined. So there's no way you can have a y-intercept when a point is undefined, okay? Whew, so knowing all that, we would go back and pick a graph, I guess. So I'll tell you what I do. I'd put all my info in, and then I'd look at these graphs down here, okay? So let me move this out of my way. So I did have vertical asymptotes at -1/4 and 2, so that's a possibility. That's a possibility. So they're all possibilities at -1/4 and 2 as far as their vertical asymptotes. Horizontal would be 0, so that's going to 0. So it looks like they all got them going to 0. So what's going to get you is that x-intercept is -2, 0. So that'd be -2, -2. I don't know what they're doing there. Y-intercept, I said there was no y-intercept. So that one's crossing. That one's got a hoe. That one is not even crossing it right. So it's got to be, which one had my hoe? So it's here. But this one here has a hoe on the y-axis and not the x. So we would want this one right here that's got the hoe at that vertical asymptote. Whew, okay. Or you would what? Graph it on the calculator and it'll spit out one of them pictures, okay? Now let me show you. If you was to graph this on the calculator, you see how they go to 4 and 4 and all that? So watch how to do that. So on the calculator, you would put the top in parentheses, x squared plus 2x, close parentheses, divided by bottom in parentheses, 4x to the third minus 7x squared minus 2x, close parentheses. Now, if you want your graph to look just like theirs, click this button that says window, and x minimum would be -4, x max would be 4, and then go down here to y minimum is -4, y max is +4. Because see how theirs go from -4 to 4? Then I would hit my graph. So y'all want y'all to see the graph. So I went to y equals, and I punched in my equation. I used parentheses around the top and the bottom of this. And then I went to this window. So let me show you how I did that. So let me do this again. I want it to be normal so I can show y'all the window. So I put in my equation and y equals, oh, come on. All right, when all else fails, turn it off and back on. All right, y equals, got my equation. So I went to the window button, which is the second one, right by the y equals. And see, it says -10 to 10. I wanted mine to be -4 to 4, like the graph. So I punched in a -4, enter, +4, enter. Then I entered down to the y minimum. I made that a -4, enter, and y max a +4. So now when you graph it, you'll see the graph just like in our pictures. So let's go see which one was. So I think I had this B right here. It's undefined. There's my, yeah, okay. I think I said this one, but it should be going down. Okay. That's the easy way. Just graph those things and be gone. All right, so the last two deal with polynomial inequalities. Let's see. 24 was the last one I took off. So this was the fifth one I took off of here. X minus 3, x plus 2, less than 0. And I didn't take this one off because it was too hard. I figured, well, this one was already factored, so I took this one off, and then I left number 25 on there for y'all. All right, so to solve this, it's already factored. So what I'm going to do is find my two answers by setting both of them equal to 0. So this is where I added 3, and I got x is a positive 3. Subtract 2, and you get x is a negative 2. And then I had y'all draw a number line and put your 2 points on here. Here's negative 2, and here's a 3. And we got to test 0. And 0 is in between negative 2 and 3. So I know my 0 is in between there, right? So put a 0 in here and see if it's true or false. If it's true, I shade that. If it's false, I won't shade that. I'll shade the outsides. So let's see what we got. 0 minus 3 times 0 plus 2 has to be less than 0. Well, this is a negative 3. This is a positive 2. So let's give me negative 6 less than 0. Negative 6 is less than 0 true. So on this one, you would shade it between the negative 2 and the 3. But remember, my answer's got to be in interval notation. Since there's no equals under that, you're going to use curvy parentheses from negative 2 to 3. The only thing shaded is in between those two numbers. Okay, so let's see. You would go up here. And see, they just wanted it in interval notation. So I'll click that and go from negative 2 to my 3. And then I would go to number 25, and y'all, 25 is the same thing, except you got to factor it, okay? So I got it, x squared plus 4 is less than 3x. So let's go to our paper, solve this. All right, so to solve this, you need a 0 where the 3x is, so you got to subtract that 3x from both sides, so that I get my x squared minus my 3x plus my 4, all less than 0. Now this one I can factor. I got an x and an x. Last number's positive, so they'll both be negative like the middle. Factors of 4 that add to get 3. Oh. There are no factors of 4 that add to get 3, so this would have a no solution. So let me go back to my, so if you can't factor it, and if you can't get nice whole numbers when you do it on the quad, so since you see down here, there's a 0 with the line through it, on that answer, you got to put that, okay? Because that's what they use for no solutions. They call that an empty set. Hey, y'all, so that's the test. So then you would submit that thing. Now, I think I missed some because I didn't see it said I haven't left all of them, but I ain't worried about that. So you would submit all that and be done with it. So we knew we missed a few that we skipped. So let's go back to close this. All right, so that's test 3 review. So I'm going to stop this recording.